is a nerve muscle preparation. Here is the nerve, and here is the muscle. This is the muscle spindle. It responds to stretch by producing action potentials in the nerve. The receptor potential is an intermediary step in this process. It can best be recorded in muscles from frogs. We have used winter frogs of the species Rana temporaria. The frog is anesthetized with urethane. It is then pithed and spread on a cork board. The gastrocnemius muscle lies at the back of the hind leg. The sciatic nerve runs deep in the thigh. It is dissected with care in order to avoid injury potentials. The dissected preparation is placed in a modified form of Krebs solution, whose composition is shown in the following table. Meanwhile, the contralateral muscle is analyzed for acetylcholine in the usual manner. The preparation is set up in a bath containing Krebs solution and oxygen. The nerve is placed on a non-polarizable electrode. It is seen now under the microscope. The impulses lead to a cathode follower, which it is necessary to use in order to keep the input impedance as low as possible. The signal now feeds into a series of Schmidt trigger stages, which are used instead of the conventional DC condenser-coupled amplifier because of the low inherent noise level and stability. The pulses are then fed into an Eccles-Jordan circuit where they are differentiated. They are then fed into an integrator. And the results are displayed on a cathode ray tube. Here are two monitor tubes in series, and in parallel there is a loudspeaker. It is necessary in a physiological experiment to distinguish clearly between true results and electrical artifacts. The principal electrical artifacts will be demonstrated on the oscillograph screen. Firstly, noise. Secondly, 50 cycles. Thirdly, injury potentials. These are not seen in carefully dissected preparations. Under suitable circumstances, the high-frequency oscillations of the receptor potential are found. The significance of this most interesting observation is that these waves are sinusoidal in shape and can be subjected to Fourier analysis if so desired. These waves are a counterpart of the Weber-Bray phenomenon. This can be readily established by means of the loudspeaker. Waveforms and sounds produced by the preparation are always identical with programs transmitted by the British Broadcasting Corporation. Angelwurzels do not do well in the springtime. And now I want to come to the problem of herbs. Now the herbs you usually...
Sempre una mattinella già rovito il pianto in viso.
From this, it is readily apparent that the muscle is not producing these sounds itself, but is in fact sensitive to electromagnetic radiation, radio waves. In this graph, frequency in megacycles per second are plotted against the number of spiral turns observed in the sensory ending by histological techniques. It turns out that the points happen to coincide with the conventional transfer function shown on the right. It will be obvious that if factorial f is the impulse frequency at time omega and psi brackets s is the impulse frequency at rest, then the product of phi omega t is contributed by that particular rate of change of deformation, nu, because pi is a time constant. The analog computer used for these calculations has, of course, a flat response up to 10 kc. The explanation of these results is that the annulospiral ending is a choke. Although the evidence is not quite so conclusive, the flower spray ending is probably an aerial. You will see from this circuit diagram that the muscle spindle as a whole is acting as the tuned inductance of a simple Hartley squegging circuit. Naturally, a receiving circuit such as this will only function when connected to an earth loop. The loop should make contact with earth through as wide a diameter metal conductor as possible. And for best results, it should terminate in a good silicone subsoil. As a control experiment, frogs have been imported from overseas. To minimize radioceptor fatigue in these animals, they are delivered at night, when broadcasting is at a minimum. We have found that British frogs, French frogs, German frogs, and Italian frogs all receive the BBC and not their respective radio stations. The only remaining question is whether the frogs can perceive these electromagnetic radiations as sound. There seems to be little doubt that this is in fact the case.